Our very first in-person Fastly Live event. Today I'm here with Dora.
Hey everyone.
My name's Kailan and we're both from the developer experience team at Fastly. And today we're here to talk to you about something really exciting, which is Passkeys. Now, if you don't know what Passkeys are, simply explained, it's just a way of logging into a website without a password, but it feels a lot like the future. And Computer Edge is a great way to help with that. And we're gonna figure out how to do that just within the next 45 minutes. So a little bit of background on Passkeys. It was announced by Apple back in June 2022 at WWDC. And ever since then, there's been so much excitement around Passkeys. I mean, no one read about OAuth 2 in newspapers, but when Apple released this, the entire world learned about it the next day. And since then, we've seen it integrated into many popular websites such as PayPal, Google, Best Buy, eBay, and many others, thanks to its security benefits and great user experience. If you've seen Passkeys in the world, let us know where in the chat, because we're really curious to know about other companies that may be making use of them at this point in time. If you haven't used Passkeys yourself, I will show you now. This is what it looks like when you sign up for an account using a desktop browser. I'm using my fingerprint with Touch ID on my MacBook, but you could just as easily use another authentication mechanism, such as a YubiKey, or even another device that supports Passkeys. This is what it looks like when you're signing in. The idea is we just enter the same email that we used before to identify ourselves, and then we're going to have the passkey requested, in which case we authenticate the same way and prove who we are. Now, there's another way that you could do this. You can do it on your mobile device. So this is an example of what it looks like on an iPhone. It's very deeply integrated into the operating system. And you'll see here, I'm just going to do the same thing, type my username, but this time I'll use Face ID, which is the chosen authentication method for my device. And there we go, we've registered. And just as before, we're going to log in using that passkey, which is even easier than before because the device has actually remembered the email that I used along with the passkey. So that's what passkeys are. But Dora, would you maybe go into a bit of detail about the technical side?
Absolutely. So thanks for that intro and demo, Kailan. Passkeys are a game changer, not just for the user. They're obviously great to use, don't have to remember any passwords, but also for the developer. They're actually pretty delightful to implement. Now, technically speaking, passkey is shorthand for FIDO multi-device credential. FIDO stands for Fast Identity Online, and that's an open industry standard that was developed by the FIDO Alliance, which is a consortium of technology companies, including all the big ones, and this is being developed specifically to make authentication more secure and user-friendly. A credential is something we've all used before. Credential is basically a piece of information that's used to prove your identity, like username and password. We call that a knowledge-based credential. So a password is something that you know. And credentials like that are usually stored on the server, which is also responsible for securing them and keeping them secret. Now, FIDO moves authentication towards something called possession-based credentials, which is something that you have, like biometrics, so your fingerprint, or facial recognition, or hardware tokens like USB security key. So credentials like that, they're typically stored not on the server, but on devices that you own. So the responsibility for securing them is with a device vendor, and to some extent also you. I don't know if any of you were eagle-eyed enough to spot the email addresses that Kailan used to sign in his demos. So he registered with different email addresses on desktop and on mobile. Had he used the same email address, he wouldn't have had to register again. And that's what makes passkeys pretty amazing. So all the big vendors, Microsoft, Google, and Apple, have decided that they're going to sync these passkeys with the respective cloud account. So you don't have to re-enroll for every single thing on every single device that you own, which is great. Now, you may also have read literature about passkeys being discoverable WebAuthn credentials. Discoverable basically means that passkeys support an authentication flow that doesn't require entering a username or any other information really to sign in. And that's partly true in theory, because browser support, as we're used with these sorts of things, is pretty early days, and it will probably lag behind and be a little bit patchy for a while. But in the future, you'll be able to just click a button that says, use my passkey to sign up or in everywhere. And finally, WebAuthn. What is WebAuthn? WebAuthn is a web standard published by the World Wide Web Consortium under guidance from the FIDO Alliance. And WebAuthn uses public key cryptography in order to enable this secure and passwordless authentication. And it does so in a pretty amazing way. But what even is public key cryptography? So it's a system that uses a pair of keys, or a key pair, two keys, for secure communication and data protection. There's a public key and a private key, or secret key. So the public key that can be sent openly through the network and shared with absolutely anybody, and the private key is just kept secret by one of the communicating parties. And this key pair can be used to perform cryptographic operations like encryption and signing. Okay, what is encryption? Encryption is used to protect the confidentiality, I will never say this word correctly, confidentiality of data. So when someone sends an encrypted message using your public key, only your private key can unlock or decrypt that message. So say we have Bob and Alex, and Bob would like to send a secret message to Alex. Now, Alex has a key pair. They keep their private key in a safe place and hand the public key to Bob. And Bob encrypts his secret message for Alex using Alex's public key. And since Bob encrypted the message with Alex's public key, and Alex never shared that key with anyone, including Bob, Bob trusts that only Alex can decrypt the message with the private key. So that's great. On the other hand, there's also something that you can do that is called signing, something quite separate from encryption and decryption. So signing is used to verify the authenticity and integrity of data. When you sign something, you use your private key to create a digital signature. And then someone else can use your public key to verify that your signature is indeed authentic and that the data hasn't been tampered with since you signed it. So back to our example, Alex's public key isn't something secret. Anyone can use it to send encrypted messages to Alex, not just Bob. And if Bob wants Alex to be able to verify that it was in fact him who sent a message, he would need a key pair of his own. And he could then use his private key to sign his messages. And then Alex, or anyone with Bob's public key, can verify that the message they're reading has indeed come from Bob and is as it was when Bob signed it. Pretty cool stuff, right? So these two keys, they're cryptographic inverses of each other, which means like what the public key encrypts, the private key decrypts, and what the private key signs, the public key verifies. And you only need to keep one of these a secret, and that's what WebAuthn is banking on to enable secure passwordless authentication. So, right. Let's get into the detail of how WebAuthn happens and how passkey authentication is done. So there are two flows, which we will call ceremonies. That's the official WebAuthn term in the standard. Registration and authentication. You need to register a passkey first before you can use it. Now, each of these ceremonies involves 3 stages and 4 parties. The user, the client, which is your front end, typically a browser, your website running in a browser. The server or the backend, which in WebAuthn world is called the relying party because you rely on it and you trust it, and the authenticator, which is the cryptographic capability that either lives on your device, so it can be the Touch ID on your phone or something else, or it can be something cross-platform, which is called a roaming authenticator, and that's something like a YubiKey. So passkeys are created either when a new user registers for an account, or when someone is authenticated and wants to associate a passkey for their existing account. So this, clicking a button, register passkey, it will initiate a three-step sequence. So first of all, the client pings the server or relying party in order to request something called registration options on behalf of the user. The server is then going to generate these options, which contain the name and ID of the relying party. Now, the name is going to be the host, and the ID is going to be the domain of the server. The server is the relying party. And also all sorts of other information in these options, such as what types of public key are acceptable, which signature algorithms are supported, and which authenticators one might be able to choose from in order to register a passkey. And the server, alongside that, also generates a random challenge that it stores before responding to the client with the registration options and this challenge. What happens next is that the client takes that response from the server and calls the WebAuthn API. Sorry, we're back. Okay, cool. So the client will call the WebAuthn API credentials create with all the data that it just got from the relying party, which will initiate a sequence at the authenticator level. At this point, a user might be prompted to verify that they are who they say they are, using a biometric or maybe a PIN, or it can even be a combination of those things. WebAuthn supports all of these flows. And provided that the user can be verified, the authenticator will then create a key pair, a private and a public key. And this key pair is going to be associated exclusively with our relying party, our server. It's also going to be stored on the user's device inside a secure capability, like, I don't know, TPM if your desktop, or secure enclave if your mobile. And then off the key pair, the private key will be used to sign the challenge that was initially received from the relying party. The magic public key, along with its credential ID that uniquely identifies it, and the signed challenge, are then sent to the client. And the client just forwards these on straight back to the server, whose job it is now to do a bunch of verifying and storing. So the server is going to use the public key it received to verify that the challenge that we stored right at the beginning matches the signed challenge that we got back from the authenticator. And provided that all checks out, the public key and the credential ID can be associated with the user, and we can store those for future authentication flows. And that's basically pretty much it for the passkey registration ceremony. So I'd like to just go ahead and implement this, and then we'll move on to authentication.
How exciting. Thank you, Dora, for the explanation there. So if you've watched our live streams before, you'll know that we typically like to build on top of our serverless platform that's powered by WebAssembly. That's Computer Edge. But today, we're not just going to be writing logic at the edge. We're actually going to be storing data at the edge using Fastly's KV store as well, which is a pretty new technology. So Dora, would you like to take it away and show us what we'll be doing?
Okay, gladly. We are going to be building this, just like in Kailan's demo at the beginning. We are going to have a form, a couple of buttons, and lots of pink. And we are going to be building this with Compute at Edge. Now, I don't know if I've said this before, but compared to, say, OAuth 2, WebAuthn is surprisingly delightful to implement. There's a lot less you have to worry about. There's nothing secret that you have to store anywhere, which is amazing. And if you want to follow along and code along with me, you totally can. There is a repo that you can clone that will bring you up to speed and give you a bunch of files that I've set up to help us on this journey. So can we post that in the chat? Great, thanks, Kailan. Cool. Standard Computer Edge project in Rust. A few special things here. So first of all, this KV store is our edge data storage. It's fairly new. It's a wonderful thing to be able to have distributed edge state without having to worry about things like replication, scaling, infrastructure, and all of that stuff that makes a good systems engineer cry. But yeah, so there's a little bit of setup required in fastly.toml that I've already filled in for you. We are going to tell our local server to make some local KV stores available so we can develop and iterate quickly locally. We're going to have 3 of those stores, one to store credentials like keys, one to store challenges because those are ephemeral, and one to store user data. So 3 in total. There's another section in this file called setup, and this serves basically to tell our deploy command, fastly compute deploy, that when we first publish the service, it should also set up 3 KV stores. That's all it takes, nothing else to worry about at this stage. Some other files here. So I've taken the liberty of pre-writing the front end. I will never be good enough to write CSS on live stream. It's your standard HTML, CSS, and JavaScript. I won't go into detail in this front end code, but basically we are using something called Simple WebAuthn. And that is a package for the browser that just wraps the web authentication API and adds a bunch of error handling. And all I've done there is to add some console debugs so we can follow along more closely what happens. Yeah, and this front-end code will initiate the web authn ceremonies, of which there are 2, if you can remember. And right now we're going to work on registration. I enjoy writing computer-edge services in Rust, so that's what we're going to do today. Here, pre-filled in main.rs, which is the entry point of our computer-edge application, is some code that serves the front-end assets and some placeholders for exactly 4 API endpoints, 2 for registration, 2 for authentication. The stages they correspond to is getting the registration options or the authentication options, and then doing a bunch of verifying. So we're going to write all of this out. Now you might notice a strange looking submodule here, OpenSSL WASM32 WASI. So computer-edge services are compiled to WebAssembly. Anything that compiles to WebAssembly, you can run on Fastly's Edge. This is like an assembly-like language that is pretty self-contained, and in and of itself, it doesn't do very much. It doesn't have file system access. It doesn't have access to libraries that you'd expect a host would have, such as OpenSSL, which we need for crypto. So I've had to compile OpenSSL to specifically to the WASM32 WASI. WASI stands for WebAssembly Systems Interface. Anyway, long story short, you're going to need WebAssembly. We're going to package it up in the WASM binary, and we're going to ship it all to Fastly's Edge alongside our service. So that was my little intro about WebAssembly, which reminds me that I should probably run this command.
Isn't it just incredible that you've compiled OpenSSL to WebAssembly and you're just casually shipping it to every Fastly cache node? I mean,
okay, the casually shipping it is incredible. The compiling bit, full confession, I learned this from our colleague Frank Dennis, using zigcc to cross-compile OpenSSL to a completely new target. So it was actually pretty easy. I say that having had massive help from a colleague. Anyway, back to our stuff. So, brief reminder of what we're trying to do here. We've just been pinged by a browser somewhere. We need to send it some registration options to start the WebAuthn ceremony of Passkeys registration. So we're going to use a crate for this called WebAuthn. I've already loaded it. So let me just, WebAuthn RS. So we're going to use this crate. Okay, I was not counting on my autocomplete is doing funny things. Anyway, so we import the prelude that imports all the functionality we need for WebAuthn RS. And we also need to say who we are, because this is the server code for a relying party. So I'm going to declare a couple of constants here. RP name. I wish it were that simple. The RP name actually needs to be localhost. And I'm going to call that origin because name is confusing. And we also need a domain. Why is it localhost? Because when we stand up Fastly service using the local development server, all of this stuff actually ends up on 127.0.0.1, not localhost. Well, localhost is a valid relying party domain. 127 blah 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 is not. So that's why we have localhost. Cool. Now we need to initialize WebAuthn, which has no mutable inner state, so we can do it right here at the beginning of our main function. The first thing we're going to do is initialize. And instead of unwrap, we're going to use a different Rust construct because I just want nicer error handling here. Okay, it goes without saying that when we publish this service, it can't be using localhost. We're going to be using the domain of our newly published edge computer, but we'll do that at the end. Next thing I need to do is initialize something called a builder. It's just the WebAuthn builder trait, make a new one with the relying party ID and origin. And we can also put an expect here to say that we weren't able to configure WebAuthn. Last step in initializing WebAuthn is running builder build. And since we are here initializing stuff that has no mutable inner state, I think it's a good time now to also open up some handles to our three KV stores. So I think the first one should be users. We're going to need to import KV store now. So initializing the KV stores here means that we can then just use users to retrieve or insert values in them later on, which we'll have to do as part of our ceremonies. So what I'm going to do here is KV store open. What do we call that? User data. User data. And then just unwrap the handle. And I'm going to do this for the other two as well. Users, what do we have? We have keys. So, and challenges. Because challenges tend to exist just between two operations, between the get option and verify the ephemeral. So I'm going to call this handle state because that's what we use challenges for. Cool. So the first one is just going to be usernames to UUID mapping. And we need UUIDs because that's the language that WebAuthn RS expects. So we're going to have to generate some UUIDs at some point. The key in the KV store for credential mapping is going to be UUID as well. It's just simpler to reason about than a username, and yeah, and we're going to use a UUID also as a key for anything related to state. Cool. Let's give that a state. What do we have to do? Okay, provide the registration options and a random challenge. Now, presumably the client is going to send us something like a username. Great. So we have that. This is a post endpoint. So we're going to have a request body that we need to destructure. And it's got one property. So I'm going to use this crate called Surday, and we're going to write a quick struct here that that is going to help us deserialize and serialize and also debug anything we get back from the front end. Just going to call this form. The username is a string. No password.
We definitely don't want a password.
We don't need passwords. That's great. So also need to use Surday here. Great. Autocomplete is truly a blessing when you're live coding. Okay, so how do we deserialize that data from the post body? So we use the request take body JSON. Yeah. We tell it to use the form struct we just created to deserialize the request body, and we're going to unwrap this. So right now, so far, we've just retrieved the username from the front end, and it's going to be available in form.username, yeah, which is going to be a string. Cool. It's a lot of deserialization you'd be writing in Rust, but that's okay. So I would normally doing this in JavaScript. Now, the difference between writing this in Rust and JavaScript right now, Rust doesn't need an interpreter, right? We just write Rust, compile it to WebAssembly, off it goes to computer's edge. With JavaScript, we have our own runtime that gets compiled with it. It's SpiderMonkey, it's Mozilla's runtime. And we don't yet support the algorithms that we need for cryptography for passkeys. There's an open issue and support is incoming, and the code for implementing passkeys is ready. I'm just waiting for that issue to be resolved on our JavaScript compute runtime. But for now, Rust. I hope you will learn to love Rust. It's a beautiful and very useful language. Now we need to see if this user we've just destructured exists in the KV store. Yeah, because we need a UUID that isn't present in the form because people don't remember UUIDs, they remember their usernames. So I'm going to use a match. Going to use the lookup string, lookup str method on Fastly KV store. That is great. I love autocomplete. Okay, if we have a user ID, an ID of any kind, let's print that out, shall we? So I'm using print line.
You know, I can't believe this, but I just realized this is the first time that I've used the KV store in Rust. It's very easy.
It is very easy. My favorite feature is not having to worry about doing any specific local setup or any specific remote setup to just get going with KV store. Cool. So we're printing that, and if we don't have a UUID, we do actually need to make a new one, which should be a UUID v4. I've just decided that. So there's no error case. GitHub Copilot really needs to learn, or I need to write more code for KV stores. So we're going to do let ID. Create a new v4 UUID and insert it into the KV store. Okay. It's my new thing. I love writing expect for error handling instead of unwrap. Cool. Now, the reason we are getting this UUID is also because when you register a passkey, because you can register more than one for the same website, right? You can choose to sign in with your Touch ID or with Face ID or with your YubiKey, and you can use all of these for the same website. So we need a way of storing the credentials that we already have registered before, retrieving them and telling the authenticator, give us a new one, give us something we don't have. So what we're going to do now is basically that bit. We need to return to the client a list of credentials that have already been registered. So let's do 2 matches here. This is going to make sense in just a moment. The next lookup we're going to do is a lookup in our keys KV store. Now that we have a UUID, we're going to look up in the keys any credentials associated with the UUID. If we have those, we are going to parse these, unwrap them. So now, passkey is a struct that exists in the WebAuthn RS crate, so we can just use it to deserialize various things. So we are going to take the string, because that's how we store this value in a KV store. You can store it as anything, you can store it in binary format, but we're storing it as a string. We're just going to deserialize this and load it into a vector of passkeys. And because we're destructuring a tuple here, we're going to return this like so. So we need a UUID, not a UUID shaped string. So we are going to parse the ID that we just retrieved. And then we are going to return an iterator from the existing credentials that we just destructured. Sorry, this is a bit. We don't need to give to the client ID entire key. All we need to know is the credential IDs that it can then forward to the authenticator to say, like, don't give me any credentials matching these IDs. I already have them. So I've done that. There's a couple of extra brackets here.
That's Rust for you.
Already returned there. And when we can't find any credentials, we're still going to need to parse the UUID. We can just return none here. That's cool. And after we've inserted, so if we didn't have a UUID, if this user just wasn't at all registered before, we still have to return this here. This isn't actually a string because we've done this with UUID new v4. This is just a UUID struct, so we can just return it. And again, none for the credentials. Whew. Right, so this is all KV store stuff. Now we need to do some WebAuthn stuff. So if you remember, we're going to need to send back to the client from this endpoint a random challenge, and we're going to need to store it as well. So there is a WebAuthn method for that returns a challenge and the challenge in a serializable format, which we can then just put in the KV store. Almost. It's not called generate registration challenge. It's called start passkey or registration. And this takes as arguments, it takes the user ID. There we go. Thank you, signature help. It takes the username, which is going to be the form username. It takes the display name, which can be the form username again, and the exclude credentials, which is an array of credential IDs, basically some identifiers associated with some public keys that we definitely have and don't want again. Cool. Now we've got these two things. We need to store something in the KV store because we'll be verifying that in a minute. And we need to store it in state. That's where we put our ephemeral challenges. So everything is keyed by UUID. Just remember we got the user ID here. We're going to insert at in the state KV store at the key UUID. We're going to insert the registration state there. Perfect. And yeah, we can respond with a status okay, but we also need to send some JSON. That's the registration challenge. So let's see what we've done there. What? Oh, Rust. Yeah, sorry. So that's actually JSON, so we need to serialize that.
It is pretty nice though that all of the types for the WebAuthn library seem to have a way to deserialize and serialize them without us needing to do it ourselves. I think that's pretty useful.
Yeah, that's brilliant. So both Rust and JavaScript have mature libraries that you can use to just implement WebAuthn. Okay, what have we done? Consider dereferencing here. Users insert. Oh, some more debugging. Just give me a minute. Oh, we don't need to pass reference. We just pass the string. Are you happy now? Fastly compute serve watch. No, you're not happy yet. Okay, we need to pass this. Love the compiler messages in Rust. Nope, still not there yet.
As Dora mentioned earlier, of course, we do support a variety of languages on Computer Edge, JavaScript being the most popular. But the beauty of Rust, although it may seem a bit more difficult or there's a steeper learning curve, it gives you really great performance advantages and security advantages. So sometimes it's worth fighting the compiler in this manner just to provide a better service for your users. And that sounds like a success.
Well, it compiles.
Yay.
Let's see what we've built. So this is our local host. I've added some debugging so we can check out the console. I'm going to write Dora here. Woo! Got a semblance of a dialogue. And if we look at that, we can inspect some of the data that we've got. Okay.
Would you be able to zoom in your developer tools so that the viewers can see? Fantastic.
Absolutely.
So
we've got the registration options and the registration response and registration verify. Hang on. What is this? This is old.
Oh no, look away.
Look away. Yeah, we haven't implemented that yet. So.
Exposed.
Excellent. And we're not getting any logs here. So wait, hang on a minute. Where are we?
In the meantime, while Dora works on that, this would be a great time to plug our social media. We definitely recommend that if you're not already, you check us out on Twitter. Oh, it's not Twitter anymore. You should check us out on X @FastlyDevs. where not only will we be posting loads of content like this, but we'll let you know about all of our new SDK updates, any cool features that have been added. It's the best place to be for those things.
Okay, we do need to verify this registration. So we've done this bit, and this is actually, we need to send to our backend now. We need to send the username and the response from the authenticator. So we're going to need to destructure some JSON with two things here. So let's write a struct here. Just a moment. Username as always, and I'm just renaming this to be more Rust idiomatic. So let's do some destructuring on the verification side of things. Okay, so again, rec take body JSON. What are we going to do with these verification? We are going to, well, we need to retrieve some stuff from the KV store. So user ID, users, look up string. At this point, we expect the user ID to exist in the KV store from the first step. We don't want this endpoint to be called unless the first endpoint was called. So it's absolutely okay to unwrap here. This will panic and will end our program if the user ID doesn't exist in our user store. We also want to retrieve the challenge that we stored. So that's cool. We retrieve that from the state. It's keyed by user ID. And we also want to deserialize the passkey registration state. This is just some JSON. We need to deserialize it into some kind of structure that our WebAuthn and crate understands. Now, if you were implementing this with, I don't know, a server like Express or another technology, the state that we are storing in a KV store would be equivalent to session storage. So that's what we're doing here. We are deserializing the state that we looked up, because we stored it in a KV store, we can now safely delete it. So we'll do that at the end. Actually, what I'm going to do now is send all of the stuff we've just deserialized in various ways to WebAuthn, finish passkey registration. It just takes we need the authenticator response. There we go. And we also need a deserialized state. So ooh. Okay, at this point, we should know whether we are able to register the user or not. We're going to need to retrieve any existing keys associated. So some of these keys have like a counter that needs to be updated every time they're used. It really depends, like on on the type of credential that you use. So for example, a specific USB key might have a counter that keeps track of how many times it's been used. So that's like an extra safety feature. But we also need to go through all of our authenticators and update the counter for the one that has just been used, even if it's for registration. So we're going to do that now. Those are all the credentials. Need to deserialize everything again. There's lots of deserializing going on into a vector of passkeys. Great. And we're going to add the newly created credential there. I'm sorry, I got a little bit confused. So we're at the registration phase. We don't need to update any counters here. We're going to need to do that in the authentication phase. Right now, what we need to do is insert the credential we've just registered and store it in our KV store. So we're going to do keys insert at the key with the user ID. We are going to serialize the existing keys as a string. And we're going to store everything. And then we can just respond with status code. Okay, our client at this point doesn't actually doesn't care about any specific response. We just want to know that it's okay. If it's okay, then we can try and authenticate because we've just registered this credential. So, Fastly compute serve watch. Oh, we're missing something here. What are we missing? That should be a little bit easier now.
I think we may have a bracket missing somewhere.
It is definitely a bracket missing somewhere. I don't understand. Oh.
There we go.
I am so sorry, folks. Give me a second. That concludes our registration. And then I have some good news because for authentication, it is more of the same. Yes, cool. So we've registered a passkey. Now let's figure out how to use it to authenticate. There's the second ceremony, authentication. So when someone wants to sign in with a passkey, they'll typically click a button. What happens very much follows the pattern that we followed for the registration ceremony. The client is going to ask the relying party for some authentication options. The relying party is going to respond with options and a random challenge, which it stores again as a state. The client is going to forward those onto the authenticator using the WebAuthn API call navigator credentials get. The authenticator might now choose to verify the user, and if all of that checks out, the authenticator is going to use the private key or secret key to sign the challenge it got and to retrieve the credential ID associated with whichever credential was used to verify the user. And finally, once the client received all of that back from the authenticator, it's going to forward them straight to our relying party, which now has the job of verifying the signature against the challenge we stored. And if all checks out, we can consider ourselves signed in. So there's going to be some copy pasting now to do the implementation bit. And let's go back to our editor. Cool, provide authentication options and a random challenge. So I like this in WebAuthn that all the stages basically follow the same pattern. So it's quite easy to write this code. Now we need to look up the user ID again. What do we need to do? We also need to retrieve and deserialize the user's credentials. So cool. I've looked those up in the Keys KV store. As you can see, my editor has now learned that I've written this code before and sort of was trying to guess what I want to do. And what I want to do is, now that I've retrieved some credentials that we've stored in our KV store, I want to make an array of passkeys, a vector of passkeys, not an array, that I can pass into the appropriate WebAuthn method. That's not what I want to do. Okay, we don't need to do all of that complicated stuff here. If I can't deserialize whatever's stored in the KV store into a vector of passkeys, something went wrong. So it's okay to say credentials corrupted and just abort the rest of the program. What I want to do is to start passkey authentication now. So the WebAuthn start passkey authentication method is going to return a challenge and a serializable state. What we are passing to it is not all of this stuff. I think we just need to pass it one thing. Okay, that's cool. We got WebAuthn to generate a bunch of things, and we need to store the state in the KV store because we'll end up verifying this. That all checks out. Is it all state I want to do? Yep, perfect. Response with status, okay.
It looks like Copilot has finally woken up.
Yep, would have been useful a little while ago, but that's great. So we respond with JSON. And yeah, and then we've responded with JSON. What happens in the client? The options, now we need to do a bunch of verification. So there's another JSON body that we need to parse in the very next method. And it's no longer a registration one, but you know, I'm just going to copy this. This is the response from the authenticator, but at the authentication ceremony. So it's not a register public key credential, it's just the regular public key credential. It exists. There's slightly less detail in public key credential that the authenticator returns at this stage because it assumes you already know about that credential, right? So let's go back to our method. I'm just going to put the terminal away for a second. This is possibly the most code I've written in a live session. I might commit it so that you can just take this and put Fastly in front of your website and enable passwordless authentication. Wouldn't that be cool? I do need to retrieve the UUID. Basically, I need to retrieve the UUID at every single endpoint. That's absolutely fine. I also need the state. So I can just go back to the registration thing and copy this part. Everything. Let's copy everything. Back here. It's not called reg state anymore. It's auth state, and we want it to be it needs to be a very specific shape. Otherwise, if it's like an old state or an unrelated state, we can just abort the program because something went wrong or someone is trying to hack us. Now we want to pass all of this stuff back to WebAuthn. Is that what we need? Yeah, looks about right. Auth, authenticate response, and auth state. And what do we want to do? Oh, okay. So this is where I got confused at the previous step. So we have some credentials in the KV store. And sometimes some authenticators, they need to have counter incremented whenever they are used, right? This is for consistency and security. So we want to get all the credentials again. And this is the point where we need to increment some counters. So we retrieved some credentials, or all of our keys from the credentials KV store, and we need to update them. Okay, great. I want to have a mutable iterator over this array. And then for each credential in this array, key, I want to use a specific method from the WebAuthn called update credential. This will actually only run if the type of credential expects a counter, so expects to have to increment a counter, so it's absolutely safe to run it for everything. Last but not least, I'm going to insert them back into the KV store again. And yeah, I can now respond to my client. And you know what? That's it. That's passwordless authentication. So I'm just gonna Fastly compute serve. Of course, I got something wrong. What did I get wrong? Unexpected closing delimiter.
Oh no.
9187.
It's okay. This happened at our last Rust live code.
Yeah, no, it was great. I love the errors here. So authentication options. No, it can't be in options because we've already written all of that. I bet it's somewhere with this iterator. We've done the iterator. Well, we're doing an unwrap and an expect.
I feel like we could present it like a children's show. Like, can you spot the extra bracket?
Let's see if that solves our issue. So, no, there's another issue. Okay, whack-a-mole. So when we responded with the auth challenge, that's the previous endpoint. Okay, we closed an extra bracket there when we shouldn't have. Okay, one more. We're nearly there, I promise. And I'm using the wrong method here. One more letter. We are so very nearly there. Come on, come on, come on. Yes.
That's more like it.
Is it going to authenticate us? Shall we try Kailan?
Let's do it.
Okay.
We're registering.
Yes.
We did it. Oh, you did it.
Yes. Now we have like all the logs here, so we can look at what gets returned at every stage of WebAuthn. Now, we're not going to go into the nitty-gritty of that, but what I will do is I'm going to check out a new branch, call it done. Put it up there so everybody can access it, and then I'm going to publish my new Fastly service. Passwordless Edge, excellent. Brightly gorgeous Molly sounds great. No backends needed. KV stores are all getting configured for me. So once all of this ships, I'm going to click it and we're going to use it. We're going to authenticate without a password in our newly created service. And yeah, you can pretty much take that and stick it in front of any website you have. Try out Fastly for free, by the way. If we can put a link in the comments, that'd be great. I hope you enjoy this. Now, having implemented Auth 2 in several languages at the edge and not at the edge, I'm really happy to say that Passkeys and WebAuthn are such an improvement, and they just, they're an improvement for users because the user experience is just so much nicer. There's nothing to remember. They're an improvement for engineers. I don't have to worry about securely storing any secrets. There's nothing secret there, right? Passkeys, unlike passwords, are virtually unphishable. If someone gets hold of my origin and tries to, say they get hold of everything that is in the KV stores, they have public keys. Public keys are useless. I don't mind that they can get my public keys. Right. You see what happened? The relying party, I should have changed that and redeployed. Anyway, it's going to work. So onto why passkeys are unphishable. Public keys, totally fine for the public to have. It's in the name. And that's all I'm storing in our KV store. If someone makes a fake website that is brightly gorgeous Maltese or has a typo, whatever, and fools me and I register there, a passkey is only valid for one relying party. So they can capture my entire passkey, but it won't work when they come back to brightly gorgeous Molly and try to authenticate and pose as me. So passkeys are like this brilliant, step up from how we see authentication. I'm really excited, and I hope I've demonstrated that it's quite easy to reason about. Remember, 2 ceremonies, 3-step each, 4 parties, and 2 of those parties you could pretty much do entirely at Fastly's Edge. There's no databases to worry about. There's no infrastructure to worry about. It's all like global, instantly available. Let's see, did we fix that bug?
We might have to wait a little while to deploy.
Have we actually deployed it? Yes.
Of course, Computer Edge is very performant. However, you can imagine that it does take some time to actually distribute your code to every single Fastly cache node in the world. So you can expect maybe 45 seconds wait while you deploy, but this is fine for debugging because you can use the local testing server. Any luck yet?
No luck yet. Did I actually save this when I deployed it?
I've certainly done that many times.
Whoops, sorry. Let's try that again. Okay, you know what? That's all going to deploy. But why don't we go to this domain in 5 minutes time, and you can let me know if it works or it doesn't work in the comments. Yeah, thank you so much for tuning in.
Yeah, thank you, everyone. And Dora, thank you so much. This has been really, really interesting. I hope that you guys have all learned something new, whether that was about passkeys or whether about how to implement passkeys. I certainly have learned a lot this week preparing for this that I didn't know. And I think next time I build an application, I'm going to be using passkeys from the beginning. It doesn't seem like there's much reason not to.
Absolutely, you should. They're less scary than you'd think. And by the way, Brightly Gorgeous Molly now supports passkeys. So you can all go and log in. And don't worry about me having your credentials because I can't do anything with them anyway.
Amazing. So thank you all so much for joining us today. We will see you again very soon. We're going to do these streams every month. We'd love it for you to tune in the future and to learn more about Fastly, learn more about the Edge, and perhaps learn about some more fun, exciting web standards. We'll see you next month. Take care, everyone.
Take care.